Welcome to this lecture. In the last lecture, we are discussing about how to go about doing requirements analysis and specification. We identified the main tasks that are to be completed during requirements analysis and specification, said that first have to do the requirements gathering and then need to analyze the gathered requirements, and finally go about doing the specification and then get the specification reviewed by the customer and other stakeholders. Now, let us look at the second activity in the development process, which is the analysis. We had looked at the gathering activity, seen the main activities that are to be performed during the requirements gathering, and then we had looked at a case study, simple case study, to understand that what are the activities and how they are to be performed. Now, let us look at analysis of the gathered requirements. So, this is the second task that we have written here in the requirements process. The main focus of analysis is to identify the requirements problems. For this, we have to go through all the gathered requirements and clearly understand what all is required by the customer, and then we analyze to identify and remove requirements problems. There are three main problems that typically exist in a requirement gathered requirements. These are called as inconsistency, ambiguity and incompleteness. Let us try to find out that what are these three problems: inconsistency, ambiguity and incompleteness, and how to identify these problems. And once the problems are identified, these are eliminated by discussing with the customer, end user, to remove these problems. Now, first let us look at the ambiguity problem. Ambiguity, as the name says, is that the requirement is vague. It is not precise enough. It can have multiple meanings. Let us start by taking an example. Let us say one of the requirements that was obtained is that all the end users or customers have the same control field. This was one of the statement made. This is actually an ambiguous requirement. All customers must have the same control field. What are the problems here? The problem is that different interpretations are possible. Does it mean that the control field is one control field which is shared with multiple customers, and if they change it, other customers are able to see it and so on? Or is it that similar control fields are present in with different customers? We need to discuss with the customer to check what was really meant. Is it that there is only one control field which is shared, and as the action done by each controller, each customer, it also affects the other customers, or is it that they have similar control fields here, same control field, but then these are independent? Now, let us look at an example of an inconsistent requirement. . 。  . 。 . 。 . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . As the name says, in the inconsistent requirement, some requirement contradict some other requirement. For example, let us say one customer says that turn on the heater and open water shower when the temperature of the chemical reactor exceeds 100 degree centigrade. But then another customer has given the requirement saying turn off the heater and turn on the cooler, not the water shower. So, the same requirement, when temperature exceeds 100 degree centigrade, the action to be taken is contradictory. Need to discuss with the customer to check which one is the correct one. Incomplete requirement, this is the third category of problems that we need to be watchful, or during analysis we need to identify all incomplete requirements and eliminate them. Incomplete requirements are the requirements that the customer has forgotten or does not realize that these will be needed. Just to give an example, that the customer has not recorded or has not expressed what will happen when the temperature falls below 90 degree centigrade. Just says that when the temperature is greater than 100 degree centigrade, do something, but then on the lower side of the temperature has not recorded any action to be taken. So, that is an incorrect requirement, it is actually incomplete. We should have actually recorded that when the temperature is less than 90 degree, heater should be again turned on and the water shower should be turned off to maintain the temperature between 90 and 100. During the analysis of the gathered requirement, must understand the gathered requirements well and then remove the ambiguities, inconsistencies and incompleteness from the gathered requirements. This is even though we just said it simply, but it is actually a difficult task. Without a working system, to have an in-depth understanding of the problem based on what the customers have in their mind is a difficult problem. The experienced analysts, that is the person who gathers requirement and specifies, they are typically called as analysts. The analysts take time to completely understand what the customers need, do the analysis and to specify. They devote lot of time here because this is a difficult task. The experienced analysts know that it is worthwhile spending little bit more time in doing the requirements gathering and analysis work well, because unless we have a clear understanding of what is to be done, it is impossible to develop a satisfactory solution. During the gathering of requirements and the analysis, several things must be clearly understood, that what are the problem that the user wants to solve, what features are needed and how can this be implemented. Because if the user wants to do something very far-fetched which is difficult to implement, we should not really accept that. We should change modifications to that which can be meaningfully solved, and then must understand what are the complexities while solving the problem. Even though the analysis activity is carried out very thoroughly, still some problems may remain, and for this formal specification technique for very critical software can be developed, because formal specification is a very expensive, time consuming task, and if some part of the software is extremely sensitive, critical parts can be, we can have a formal specification after we have developed the requirement specification document. Now, after we have removed all inconsistency, anomalies, incompleteness from the document, we go about documenting the requirements. Now, let us see how to write the SRS document. This is a very important skill. Let us see how to go about. Now, let us look at the specification task, that is how to write the requirements document. Here we have the gathered requirements and all the problems from them have been removed through the analysis activity, and now we get down to systematically organize the requirements and then document them properly. The SRS document is a very important document used by various types of users, and our document should be written SRS document such that it can be understood and useful to different users, because they may need look for different types of information in the SRS document. It serves as a statement of the user need, it is a contract document, it is a reference document for the development team to start development work, for the testers to design the test cases, and also it is the definition of the problem based on which the developers start to develop the work. The SRS document should be written in the form of a black box specification. What do we mean by a black box specification of the problem? The black box specification is actually the functionality as can be observed externally, that is what is input to the system and what gets output to the by the system. The system appears as a black box. We do not know that based on the input data which function here does what, etcetera, etcetera, but we know that what will be input, and based on this what output will be generated, that is the input output behavior. The internal details we should not document or try to document, we just document the input output behavior, that is based on input what sort of output should be produced. In other words, we can say that the SRS document should focus on what needs to be done based on the input data, what the system should do. Rather than how to do. The requirement document should be written in end user terminology, because it is the end users who will see whether all the requirements have been satisfactorily represented. It is written as a document which can be understood by several types of users, that is the end user, the testers, the project manager, the development team members, and so on. But then if some parts are very critical, separate formal requirement specification document can be written for that. Now, let us see, before starting to write a document, or what should be the sections, how should we go about writing the subsections and so on. Let us see overall what exactly is a good SRS document. One is that it should not be too verbose, it should be use the minimum writing that is needed, it should be concise, and at the same time it should not leave out details or be ambiguous. It should be a black box specification, should specify what the system must do and not say how to do it. It should be easy to change, that is, if some functionality tomorrow changes, we should be able to change very quickly. And how do we ensure that it is the document is easy to change, is that we have to structure it well. Like if you want to change one functionality, we should be able to change one place, should not have to change at multiple pages, different places and so on. It should be consistent, these different functionalities, they should be consistent, should be complete, all functionality should have been represented in the SRS document, and also it should be traceable. Traceable means as each functionality identified in the SRS document is implemented, we should be able to identify a functionality is implemented by which part of the design, which part of the code and so on. To be able to have traceability, the first thing is that we have to have proper structuring of the document. For example, the functions have to be precisely written, each function should be identifiable by a number or something and should be written at one place, and then it should become possible that given a design element, we should be able to tell it implements which functionality, or given a code segment that we want to change, let us say, or we find a error in a code segment, we should be able to tell which functionalities would have got affected. So, this is called as traceability, very important concept, that given a function requirement number, should be able to tell which part of the design implements that and which part of the code implements that design. Also, in the other way, given a code element, should be able to tell it implements which part of the design and also which functionality. The SRS document should be written such that it is verifiable, that is, should be easily, we can write test cases and check whether it can be, we can clearly say whether the requirement is satisfied or not. If we have a requirement like, let us say, the developed software should be user friendly, it is very difficult to test. Even if we test for user friendly, then it may not be accepted by all. We might check that it is user friendly, but then others may not agree. So, this is a very difficult requirement to verify. While writing the requirement document, we have to ensure that every requirement can be tested satisfactorily. SRS document should not include not only the how to aspects, but other things like, let us say, project development plans, like what will be the cost, staffing, schedule, tools to be used, etc., because the SRS document is used even after the development work completes. So, the lifetime of the development plans are till the development completes, but the SRS document outlives that, and SRS document should not include development plans. Similarly, it should not include testing assurance plans, configuration management, test plans, quality assurance, because they have different audience and different lifetime. The SRS document has several audience, and we write only those aspects which are of interest to all the audience. The designs etc., they are also not to be included. Now, let us see how to go about writing the SRS document. There are 4 important parts in any good SRS document. Possibly the most important part, the functional requirements. And then we must identify the external interfaces, the external software and hardware with which the software needs to interact, and the users. And then the non-functional requirements. We will see that there are some requirements which are not cannot be specified as functions. We will see what is the distinction between a functional and non-functional requirements. We have to have a section on the non-functional requirements and what are various constraints on the system. For example, one constraint may be that it has to follow certain standards, or maybe that it has to use a open source database. First, let us concentrate on the functional requirements, because this is the most important part of any SRS document and it forms the bulk of the document. Here we identify what are the functionalities or facilities that the software will offer to the users, and we document in the form of the input that the user will have to give, the output that will be produced, and also we have to mention that what would happen when the user gives invalid input. Identifying the functional requirements is a very important skill. Just to give an example, let us say give you a problem that you have to develop a libraries software. So, what are the functionalities that it should have? Or let me give another problem, that is you are asked to develop a word processing software, that is somebody should be able to write a document, something like a Microsoft Word or something that will be a good word processing software. So, what will be the functional requirements of that? To identify the functional requirements, we have to see what facilities it provides. For example, let us say a library software, we have to look at who are the different users, the librarian and then the library members and possibly the account. Now, then we have to look at what are the facilities required by each type of user. A library member might like to issue book, return book, query whether a book is available. The librarian might like to create members, might like to delete members, might like to check if there is fine against anybody, might like to create books, delete books, etc. The account might like to check what is the financial position, might like to enter the grants, might like to enter the fees, might like to register the expenses and so on. So, from each user's perspective, we have to look at the software in terms of the facilities provided, and each facility is basically some meaningful work that the user can accomplish using that. And once we have identified the functional requirements, each functional requirement we need to document. For every function, we need to describe what will be achieved and what are the approaches and techniques that will be deployed, and also we need to identify the input and output. Typically, every function requires a input. It does some processing and produces some output. For example, a query book function for a library software. In the query book function, the user gives the name of the book. So, that is the input. The software checks the book database for those books which match the user query, and then it produces the output. So, every functional requirement must be documented in the form of a overview of what the functionality will achieve, and then if possible we need to identify the input and output. For every functionality, it may not be feasible to produce think of the input and output. We will look at more details of how to document the functional requirements, but the end of this lecture must be clear about what is a functional requirement. A functional requirement is a facility provided by the software using which user can get some meaningful piece of work done. Let us now stop here, and from this we will proceed, we will look at more details of functional requirements, non functional requirements, constraints and so on in the next lecture. Thank you.